All right, multiplying polynomials, section 15.2. Now on to task 2. So now that we know what a polynomial is, and we know it's the name for things, standard form, its terms, the degree, now we can do some multiplication of it. So here we have an algebra tile diagram that represents the product, the multiplication, of a monomial and a binomial. So first we want to identify the factors. Again, the factors are the things being multiplied. Things being multiplied. And product, what you get when you multiply. Okay, so the factors are the things being multiplied. So let's come over here and look. If you remember these yellow bars, so this yellow bar here is an X. Now here we have just simple red squares. Each one of those red squares is a -1, hence why they each have a negative on them. And they're not the long bars, so they're not X. So here I have 1, 2, 3, 4, -1. So that would be a -4. So on this side, I have an X and 4 negatives. So I could rewrite that as an X plus 4 negatives, or X minus 4. So there is my binomial, two terms, an X and a -4, binomial. Now on this side, we just have two X's. So we have two X's, X and an X, two X's. Okay, so we're multiplying a 2X times an X plus a -4. So to show that, I'm going to need parentheses around that binomial to show that I'm taking the 2X times this whole thing. If not, here in red, if it does not have parentheses, the only thing being multiplied are those two things. And that's not what's happening here. I'm not just multiplying the 2X and the X. So that is inaccurate. We have to have parentheses there. Okay, so now if we multiply these, let's see what we get. If you remember, each one of these guys was an X squared. So I have two of those. I have two X squareds, because a positive times a positive is positive. Now here I have negative times a positive. So each one of these is a -X. So I have how many? Each of these is a -X. I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 negative X's, so -8 X's. Okay. So when I multiply these two, I get a 2x to the second and a -x. So I end up with 2x to the second plus a -x, or 2x to the second minus 8x is what I get when I multiply them. Okay, using algebra tiles. Okay, just to get familiar with what they look like and how they work. I do have actual algebra tiles that we can get our fingers on if you'd like to. Okay. All right, so here we kind of used algebra tiles. We can also use an area model to represent the product of two binomials. So here I have a square, a rectangle, excuse me, and this length is x plus 5, and this length is x plus 3. So the area inside would be the product of those two. Okay, so I'm going to, this is kind of like algebra tiles, but not quite, because we're not going to tile it out. Basically, my two terms here are an x and a 5. So I have an x and a 5. We're going to kind of table them out. Okay, and then over here, my two terms are an x and a 3. Okay, and now I'm going to draw boxes. So in this box is x by x. So inside here is x times x, which we know is x to the second. Okay, so we're basically finding the area of each of these pieces. Okay, so now the area inside this piece, this length is x long because it's the same as that one. This length is 5, so this would be x times 5, which we tend to write as 5x. Okay, now the area of, let's switch purple, this side is 3, this length is x, it's the same as that, so this would be 3 times x, which we again is write as 3x. And then this last one here, this one's 5, this one's 3, because it's the same as that, so this would be 5 times 3, which is 15. So I now just need to take the area of each of these pieces and add them. So I would add each of these pieces up. So I would have x to the second plus 5x plus 3x plus 15. But these two are what we call like terms. They're both x's. If I have 5x's plus 3 more x's, I have 8x's. So I end up with x to the second plus 8x plus 15. Double check, is it in standard form? There's 2x, that's x to the second, 2x to the first, no x's. Yep, so there we are in standard form. So there is my solution. And that's using that area model, which in that area model, we can even shorthand further and do it as a table. Okay, so basically we're going to do it as a table, which instead of, so, and it's basically a table there, is to multiply. So let's go ahead and let's multiply another one, and I'm going to show it two different ways. We're multiplying x minus 8 times 5x plus 3. So first is to identify all your terms, and this is where that plus and negative comes in. That minus 8 becomes plus a negative 8. So then this, my two terms are an x and a negative 8. So I go ahead and write those down in my rows. And then, oh, I forgot this guy. Okay, now in purple, this guy, my terms are a 5x and a 3. So now in my table, I'm going to multiply. So I multiply the 5x and the x. So, and then sometimes we'll actually write that 5x times x, times x, which is 5x to the second from our last section. And this one would be 3 times an x. So 3 times x, which we write as just 3x. Now this one would be a 5x times negative 8. So 5x times negative 8 would be negative 40x. And this last one would be 3 times negative 8, negative 24. Yeah, 3 times negative 8. And then now we add up all our terms. So this is just, I don't have any other x to the seconds. We're adding these pieces. I don't have any other x to the second, so I just have 5x to the second. Now here I've got a negative 40x and a 3x. I can add those. Negative 40 plus 3 would be a negative 37x. And then last here we've got our plus a negative 24. So then now in standard form, we'd end up with 5x to the second minus 37x minus 24 when I multiply those. Okay, so this is using the table method. And the table method does work. Okay, another method is the distributive property. Okay, basically we're distributing x plus a negative 8 times 5x plus 3. So I'm going to start by multiplying by this first x times both pieces in this other binomial. So I would take x times 5x plus x times 3. That's me multiplying by x. Now I do the same thing with my negative 8. Plus, now it's always addition if you rewrote your negatives right. Negative 8 times 5x plus negative 8 times 3. So now x times 5x is 5x to the second, 3x plus a negative 40x plus a negative 24. Now if you put together my like terms again, those are both x's. I can add them. 5x to the second, negative 37x minus 24. I get the same result, but I didn't have to write the table. Okay, so it's completely up to you which method you choose. But I will tell you that I tend to stick in the distributive property because it doesn't involve me having to rewrite it as a table. And I'm all for efficiency. I don't want to have to write it again. I just want to write the problem down and do the multiplication. Okay, so let's go ahead and let's do another one, but instead of binomials, we have trinomials. I'm just going to do this one using the distributive property. When I first write down my problem, I rewrite my subtractions as plus and negative. Please, please do that. It will save you so many negative issues. Okay, now I like to color code sometimes when I'm working. It's easier for me to color code on the iPad, but you can use different colored pencils, different colored pens. I need to multiply by x, so I'm going to multiply x times each of these. So I have x times 2x to the second. I would end up with 2x to the third because I've got 3 x's. I'm doing that multiplication in my head. If that's tough for you, you can go ahead and rewrite it. That's fine. Okay, so x times 2x to the second. So now I'm taking x times a negative x, which is going to give me negative x to the second. X times x is x to the second. Positive times negative is negative. Now I'm taking x times 4, which is 4x. So there, I multiplied all three of these terms by the x. Now I need to come in and multiply each of those terms by the 7. Plus 7 times 2x, 14x to the second. 7 times negative x is plus a negative 7x. And 7 times 4 plus 28. Now I come through and I put together like terms. So I look for here, and I always like to kind of kill two birds with one stone. Look for like terms, but also like largest degree. So I'm kind of already in standard form. So I have 2x to the third. I don't have any other x to the thirds in here. So that's my first term, 2x to the third. Now I have a negative x to the second. That's not an x to the second. Ooh, that one is though. So I have a negative 1 and 14. So when I add them, I get a positive 13x to the second. So those are taken care of. Now, here I have a 4x. Here I have a negative 7x. A 4 and a negative 7 is negative 3x, which I'm just writing as subtract 3x. And then the last term, my constant, is plus 28. Now we always double check. Are we in standard form? X to the third, 2, 1, 0. I have all my plus and negatives done. There is my final result from that multiplication.